John von Neumann. John von Neumann was a Hungarian-American mathematician. He was a pioneer of the application of operator theory to quantum mechanics, and a key figure in the development of game theory.
Game theory, and it's the branch of math that deals with picking outcomes when there are multiple factors at play, each with a different goal. Like when you and your friends are playing Monopoly, or flag football, or, well, any sort of game, which is where it gets the name game theory. Totally didn't see that coming, right? But game theory wouldn't be of much use if all it did was help you win at risk. Fortunately, there are some much bigger scale games out there like economics, psychology, politics. You may not be placing a pawn on start and rolling a die, but you are trying to win something. Okay, so you run a shop where you sell tongue depressors. Guess you decided to go where the really big money is. But guy across the street has opened another tongue depressor shop. You have to outsell him. No, like, you really want to bury this guy. But how? Well, enter game theory. If we suppose both shops are selling their wares for equal prices, there are a few ways this game could go. Possibility number one. You increase your price and the other guy also increases his price, and, well, that's a wash, no change in market share there. Possibility number two. You increase your price and the other guy decreases his price. Now customers are getting the same thing for cheaper across the street. Well, you lose. Bye-bye. Possibility number three. You decrease your price and the other guy increases his price, and, well, the exact opposite. Now you're going to clean up. Last possibility. Both of you decrease your prices. Well, another wash. So by using game theory, and in this simplified example, maybe a little common sense, you've determined that if your competitor raises his prices and you lower yours, he'll be done and dusted before he knows what hit him. Game theory is used in philosophy to help explain why people act the way they do, in biology to get a handle on where the apes went wrong and evolved into us, and in a zillion other fields. So as you can see, game theory, despite the name, is still math. It uses all kinds of numbers and equations and matrices to show the strategies that should be used to maximize our advantage and minimize our opponents.
Pythagoras,
The father of mathematics and music.
mathematics and music?
Ah, you'll find mathematics in the darndest places. Watch. First, we'll need a string. Stretch it good and tight, plunk it. Now divide in half. Plunk again. You see? It's the same tone, one octave higher. Now divide the next section. And the next. Pythagoras discovered the octave had a ratio of 2 to 1. With simple fractions, he got this. And from this harmony in numbers developed the musical scale of today. From these eggheads, the Pythagoreans, with their mathematical formula, came the basis of our music of today. It was our old friend Pythagoras who discovered that the pentagram was full of mathemagic. The two shorter lines combined exactly equal the third. And this line shows the magic proportions of the famous golden section. But this is only the beginning. Hidden within the pentagram is a secret for creating a golden rectangle, which the Greeks admired for its beautiful proportions and magic qualities. The star contains the golden rectangle many times over. It can mathematically reproduce itself indefinitely. All these rectangles have exactly the same proportions. This figure also contains a magic spiral that repeats the proportions of the golden section into infinity. To the Greeks, the golden rectangle represented a mathematical law of beauty. We find it in their classical architecture. The Parthenon, perhaps one of the most famous of early Greek buildings, contains many golden rectangles. These same golden proportions are also found in their sculpture. In the centuries that followed, the golden rectangle dominated the idea of beauty in architecture throughout the Western world. The Cathedral of Notre Dame is an outstanding example. The Renaissance painters knew this secret well. Today, the golden rectangle is very much a part of our modern world.
The Turing test, created by pioneering computer scientist Alan Turing, comes up a lot in sci-fi culture and discussions about intelligent robots. But what exactly is the Turing test, and what does it mean if a computer passes it? Alan Turing first described what we call the Turing test in a 1950 paper. Turing wanted to answer the question, can machines think? To get to the bottom of this, he devised a hypothetical test. Imagine a game with 3 players. One player, the interrogator, is isolated from the other 2 players, one of whom is human and one of whom is a computer. The interrogator's job is to try and figure out which is the human and which is the computer by asking questions of both. To make things harder, the computer is trying to make the interrogator guess wrongly. In other words, it's trying to be as indistinguishable from a human as possible.
What's 75 degrees Fahrenheit in Celsius?
75 degrees Fahrenheit.
Spell Fahrenheit.
Fahrenheit. F-A-H.
Self-driving cars. 8 years ago, Google brought the automobile industry into Silicon Valley, declaring a marriage between cars and big data. Since then, Google has been feeding the cars system with petabytes of data on roads and traffic. Today, the cars are being tested without a safety driver for the first time. We are entering an age where we will be enjoying commercial self-driving cars, which can hopefully cure the epidemic of road accidents that claim over 1 million lives every year. For instance, human error can run a car into a streetlight pole. Self-driving cars will be able to avoid this in the future.
Gottfried Wilhelm von Leibniz was born in Leipzig in what was then the Holy Roman Empire in 1646. He wrote his first book on the combinatorial art at the age of 19 in that fateful year 1666. Leibniz worked out elements of calculus in 1675 independently of Newton, and we actually use Leibniz's version, not Newton's. But what did Leibniz discover back in 1675, over a decade before the publication of Principia? Well, he used integral calculus for the first time in history to find the area under the graph of a function, which might not sound impressive, but it is. In doing so, he made up some important notation or symbols, including the d for differentials and the integral sign, which is a long S standing for the Latin word summa, or highest. We still use Leibniz's notation today.
Luca Pacioli. Most of us don't know who he is, but all of us depend on what he's given us. He's the father of accounting as we know it. The unsung hero of the Renaissance.
Luca Pacioli was an important figure in the Renaissance, and his life and work underlines the essential interrelationship between art, business, and science of his time. Without this relationship, the Renaissance could not have taken place.
The success of the personal computer industry and Microsoft is based on the spreadsheet. And the spreadsheet is a direct evolution of the double entry system published by Luca Pacioli.
With the publication of his Summa, Pacioli's place as a major intellectual figure of the Renaissance was guaranteed. The Summa was so important, it was one of the first documents chosen for printing here in Venice by the new Gutenberg press. Today, nearly 5 centuries later, the Gutenberg printed Summa retains its color, texture, and clarity. Its full title speaks of a book about mathematics, the collected knowledge of arithmetic, geometry, proportions, and proportionality. But just one small section within the book is what changed the future of business and economics forever. It's the section that earned Pacioli the title Father of Accounting. Through the Summa, Pacioli became the catalyst that launched the past into the future, lifting the curtain on the economics of the Dark Age, and lighting the way to unprecedented economic growth and change.